Welcome to this introduction to Azure Kubernetes Service. In this video, we will explore AKS, which is Microsoft's managed Kubernetes solution on Azure. Azure Kubernetes Service provides a powerful platform for deploying and managing containerized applications at scale. Throughout this tutorial, we will cover the fundamental concepts, architecture, and key features that make AKS an essential tool for modern cloud-native development. Azure Kubernetes Service, or AKS, is a fully managed container orchestration service that simplifies the process of deploying, managing, and scaling containerized applications using Kubernetes. The key advantage of AKS is that Microsoft handles all the complexity of the underlying infrastructure. This means you can focus entirely on building and running your applications, while Azure takes care of cluster management, upgrades, patching, and system maintenance tasks. Essentially, AKS removes the operational burden of managing Kubernetes clusters, allowing developers and operations teams to be more productive. AKS offers several compelling benefits that make it an attractive choice for container orchestration. First, it provides simplified management through automated upgrades, patching, and monitoring, all handled by Azure. Second, it is cost-effective because you only pay for the agent nodes that run your workloads, not for the cluster management infrastructure itself. Third, AKS delivers enterprise-grade security with integrated Azure Active Directory, role-based access control, and network policies. Finally, it supports auto-scaling, allowing both your applications and infrastructure to scale automatically based on demand, ensuring optimal performance and resource utilization. The architecture of AKS is divided into two main components, the control plane and node pools. The control plane is fully managed by Azure and includes critical components like the API server, which handles all Kubernetes requests, the scheduler that assigns pods to nodes, the controller manager that maintains the desired state of your cluster, and the etc. database that stores all cluster configuration data. You never have to worry about managing or maintaining these components. On the other side, you have node pools, which you manage. These contain the worker nodes that run your actual workloads, the kubelet agent that communicates with the control plane, the container runtime that executes your containers, and most importantly, your applications and services. Understanding core Kubernetes concepts is essential for working with AKS first. We have pods, which are the smallest deployable units in Kubernetes and can contain one or more containers that share resources. Next are deployments, which manage pod replicas and enable rolling updates declaratively, allowing you to update applications without downtime. Services provide stable networking endpoints to expose your applications, ensuring consistent access even as pods are created and destroyed. Finally, namespaces provide logical isolation for organizing cluster resources, allowing multiple teams or projects to share the same cluster while maintaining separation. Node pools are groups of nodes with identical virtual machine configurations that run your workloads in AKS. There are two types of node pools. System node pools are required in every AKS cluster and host critical system pods like Core DNS and Metrics Server. These ensure that your cluster functions properly. User node pools, on the other hand, are where you run your application workloads. You can create multiple user node pools with different virtual machine sizes and configurations to match the specific requirements of your applications, such as CPU-intensive or memory-intensive workloads. AKS supports two primary networking models. The first is Kubenet, which provides basic networking where nodes receive virtual network IP addresses, but pods use network address translation. This model consumes fewer IP addresses and is simple and cost-effective, making it suitable for development and testing environments. The second model is Azure CNI, or Container Networking Interface, which offers advanced networking. In this model, both nodes and pods receive virtual network IP addresses, enabling direct pod connectivity. Azure CNI supports network policies for controlling traffic between pods and is the recommended choice for production environments due to its enhanced security and flexibility. AKS provides multiple scaling mechanisms to handle varying workloads efficiently. The horizontal pod autoscaler automatically scales the number of pod replicas based on CPU utilization or custom metrics, ensuring your application can handle increased traffic. The cluster autoscaler adds or removes nodes from your cluster based on pod resource requirements, optimizing infrastructure costs by scaling down when demand is low. Additionally, the vertical pod autoscaler adjusts CPU and memory requests for running pods, helping optimize resource utilization by right-sizing containers based on their actual usage patterns. These auto-scaling features work together to provide both application-level and infrastructure-level scalability. Security is a critical aspect of AKS, and it provides several built-in features to protect your clusters and workloads. Azure Active Directory integration enables centralized identity management and authentication for your clusters, allowing you to control who can access your Kubernetes resources. Role-based access control, or RBAC, provides fine-grained permissions, letting you define exactly what users and service accounts can do within the cluster. Network policies allow you to control traffic flow between pods using Calico or Azure Network Policies, implementing micro-segmentation for enhanced security. Finally, Azure Key Vault integration enables you to securely store and access secrets, certificates, and encryption keys, keeping sensitive data protected. AKS is well-suited for a variety of use cases in modern cloud environments. It excels at deploying and managing microservices architectures, where applications are broken down into small, independent services that can be developed, deployed, and scaled independently. AKS integrates seamlessly with CI/CD pipelines using Azure DevOps or GitHub Actions, enabling automated application deployment and continuous delivery. It is also powerful for running machine learning workloads, providing the infrastructure needed for training models and running inference at scale. Additionally, AKS is ideal for batch processing, allowing you to execute large-scale data processing and analytics jobs efficiently. These use cases demonstrate the versatility and power of Azure Kubernetes Service for modern application development.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.